Machine Learning Operations and Data Science Meetup Group. Thank you so much for taking the time to join us today. So whether you're a student or a seasoned professional, I think the talks that we have planned for you are going to be very useful and relatable to you. There's food and beverages around, so please grab them if you haven't already, because this is when the commercial break comes in before the main show. So my name is Benjamin, and I'm a machine learning engineer in DKatalis. At its heart, DKatalis is a fintech company. We are the engineering arm that created the Jago app for Bank Jago. And if you don't know what Bank Jago is, it is a digital lender based in Indonesia that has joined forces with the fintech platform GoPay to offer digital banking services to Indonesia's unbanked and underbanked consumers. We're spread across all over the place. We mainly come from Jakarta, Pune, and of course Singapore. But we have also a sizable number of remote workers around the world. And speaking of working, we are hiring. You can hit the job board at the link you see here. If you're interested in knowing more, you can find the folks who are wearing the same colorful shirt as me, or the people who are raising their hands after the talk. Raise your hands, guys. Ta-da! We welcome talks from anyone, whether you're a student dipping your toes into ML Ops and data science, to a seasoned professional who is wrangling with Jupyter notebooks and pipelines all day long. However, we aim to keep the presentations approachable to a wide audience as much as possible. So just head up to meetup.com and search for Machine Learning Operations and Data Science Meetup Group SG, and you'll find the link in the description below. Finally, if you attend meetups for stickers, we've got you covered. Huge props to Cecilia, our designer, who has made everything pretty, from designing the meetup banner page to the stickers you see here. I'll leave the stickers somewhere visible, so at the end of the talk, feel free to grab some and make your colleagues jealous. All right, end of commercial, and let's get on to the main show. I'm super happy now to introduce Varun, my fellow machine learning engineer. Varun is what I'll call a full stack data guy. He started out as a software engineer, then went on to be a data analyst for some time. After that, he became a data scientist for quite a bit, but then he finally saw the light, and now he's an MLE at DKatalis. He likes Python, but secretly wants to change everything to Golang. Please help me welcome Varun.
Yes, thank you, Ben, for that introduction. Go is powering Kubeflow, so I'm pretty sure you will also love it just as much. Okay, today's topic is mainly on like data drift detection, and we want to start off with what is exactly data drift, right? Now, whenever we start off building a model, we make the assumption that the real world data is going to replicate our training data, right? And we spend a lot of effort during training to make sure that when we have the training test and validation sets, that we match that certain distributions of all the features are proper. The output variables distributions should also be matching. But when this model goes into production, and it's quite difficult to actually identify how the distribution is in production is, maybe the features or even the thing you're predicting, right? And so in reality, what's going to happen eventually is that this relationship won't be valid for too much. And basically, more often than not, with time, it will change. Like for example, to give an example of data drift, we have a credit risk model. So credit risk model, what it does is that it gives a probability of a loan not going bad, a probability of person repaying the loan. Now imagine that we start off our model and we have data for higher income households. But with time, it's possible that we may explore markets and we may start off with going to regions with a bit of lower income. Now, if we do not take that into account, it is possible that the model performance will degrade with time. So keeping track of this is quite critical. So extending on the drift, there are mainly two types of drift. One is you have the feature drift, which basically means the distribution changes associated with the input of the model. So if you have a shift in the statistical properties of your independent variables, now of course some models may be more resilient to minor changes, but if we ignore the facts that if it strays too far away from what we are trained for, then the model performance will inevitably suffer. And the second, we have the concept drift, which is basically when the relationship between your input variables and your model output changes itself. Now, for example, say during recession time, you have a people who you were considered earlier to be more viable for lending money to are no longer matching the same case. So now you probably have to look into other factors which is suitable for identifying how money lend worthy the person is, right? Now, concept drift can be gradual. So you can have case where it's something which increases with time. For example, today we have Bank Jago, and tomorrow during some time, you may have more competitors. And as a result, it is possible that they provide stiff competition. And that's if we don't account for that, then it will, our models may not perform as well as we want to. Yeah, and it can also be sudden. I'm sure a lot of models have been impacted by COVID-19. And we can also have seasonality into models. Now, seasonality is basically associated with time series data. But if we don't take that into account, then the relationships can change with respect to time. Yeah, so the main difference between the two is that data drift does not necessarily mean there's a change in relationship between your input features and your output. But concept drift means that there can be an impact in that relationship itself. Right? So why should we detect drift, right? Now, there are some models out there which are basically for like user engagement, you can say, like maybe to get more engaged users, or you may have improving the efficiency of a bank's internal process, things like that. But there are also models which are quite critical to us, to the business as such. Now, some of them can be like AML, fraud, credit risk. And for example, in case of AML or fraud, it's not always possible to get a ground truth quickly. So the way it happens is that you'll have some investigators who will investigate a certain case, and then after some period, they'll eventually tell us, was it AML or not? Now when you identify it, it may be a bit too late. And as a result, it should be important for us to identify if anything is wrong with the model much earlier than waiting for the ground truth to be available to us, right? So that's the main reason why we have to try to look out for anything possible to identify issues with the model as quickly as possible. Right, so now that we know like what data drift is, the different types of data drift, and why we need it, we basically need a tool which will help us to identify this and track this. The tool that we chose is Evidently, and Evidently, it does a bit more than data drift itself. It helps you to do model performance and data quality checks also. But the features we liked more of them was mainly data drift and target drift, which we used. It is a Python package, and it's quite easy to install. You just do a simple pip install, and it has mainly features. Of course, the most important thing about Evidently is that it works well with our ML infrastructure. So, which I'll get to later. But yeah, so Evidently has all basically the dashboard features which help us to drill down on the data drift, like feature by feature. And we'll show an example at the end of the slides, both for the batch as well as the API side of it. Yes. Now, going ahead, we have, so just for background knowledge, kind of statistical tests that Evidently uses. So the package itself takes into account on what test is most suitable for your data, but it's something that even you can plug in yourself, and you can even define your own custom tests as required, right? So basically, most of these tests like KS tests, goodness of fit, just a proportion test, are just trying to compare if the distribution matches the probability distribution function of your feature. So the two proportion Z test will just try to identify if there's a difference between the two proportions provided to it. The Wasserstein distance actually just identifies the distance between the two distributions, and so does the Jensen-Geertz divergence. It has other two tests which you can plug in if you want to. That is the KI divergence or the PSI, right? Yes. So going ahead, basically we have two main forms of deployment, as most organizations will do, I guess. One we have is the models which are deployed as an APIs or endpoints, which you can basically hit and get a prediction of some sort. And then we have Kubeflow pipelines. That is mainly for our batch jobs. Yeah. So to just give a brief background about things like the backend that we use. So we use Knative for our deployments of our API-based services. They again run on Kubernetes. The great thing is you just provided one YAML file and it takes care of all the pod definition, the scaling, routing, and traffic management. Yeah, it's quite easy to use and something that has turned out to be quite working well for us. And then we have the one and only Kubeflow, which is our main ML platform. One of the ways we run our batch pipelines is by using Kubeflow pipelines. And this is how a pipeline looks like. So it's, if you can look at it, it's basically a set of components connected together. Each component runs in its own Docker container. And well, yeah, we can basically direct the flows. We can get visualizations. We can even store any artifacts if we want to. Yeah. So yeah, the Kubeflow pipelines. Yeah, for those, I think, how many of you have worked on Kubeflow before? Only two, three, obviously. Yeah. So yeah, I mean, maybe if not, then there are other tools which are the more popular tools like Airflow, which basically you build tags and you have a UI to nicely visualize the tags. Yeah, we chose Kubeflow because it works really well with all the other tools that we have in our ecosystem, may it be Feast or for our feature store purposes, or MLflow, which is our main model registry and experiment tracking system, right? And it's quite easy to use, and you can easily define in a code the whole pipeline, which can then be used to basically run your ML logic. Yeah. So yeah, so how did we actually make Kubeflow and Evidently run together? Now, as I told earlier, there are, I mean, things called, the pipeline is built of Kubeflow components. Now, component is nothing but a reusable artifact, which one can use to basically run a code multiple times. Now, for Evidently to run, at a minimum, it needs two things. It needs a reference data set. Now, this data set is usually the data set used during training times, right? And you need an inference data set. That is the real world data that you're going to subject your models to, right? And there are other parameters that one can provide. Now, they can be something like thresholds. So basically, if you're using, say, a distance-based metric or distance-based statistical test, like if the distributions are further away than this, then throw an alert. Or obviously p-values, if it's less than a certain criteria, then throw an alert, right? And the component usually lies between the fetch data and the prediction data, predict the model, because we would ideally want to identify drift before we look into model prediction, right? Yeah, it's the component itself gives multiple outputs. One, it gives the if drift is detected or not. And for further reasons, if you want to analyze feature by feature, it also provides a beautiful dashboard which you can use for drilling down to what exactly is the reason for identifying feature drift, right? So this component, I have made it available in GitHub. You guys can try it out. Along with this, there is a sample pipeline which you can run to just test it out. Yeah, so the component itself just reads the reference data set and inference data set. We need to provide some column mapping. Evidently, we infer it itself, but I think that it's better that you provide it because it's not that straightforward. So column, and apart from that, it runs the data drift profile. Now, a profile is nothing but a JSON output of whatever drift detection it has performed. There are other profiles like target drift, like categorical target drift, numerical target drift, but this one is only using data drift profile, and it gives a data drift score of its own for each feature, and we also get the ratios of number of features drifted or not. And finally, we have a dashboard, which is available in the Kubeflow tab itself for the visualizations. And yeah, we can see it there. So this is one of the dashboards that we had generated for one of the models. Yeah, we can see that most of the features have drifted. And yeah, basically there's a lot of things that can be done once drift is detected. And I'll get to that in the last slide of this presentation. Yeah. So the other case that we have is an online data drift case where some of our models are deployed as API based, and we use mainly fast API for our for deploying our models. And basically, in this case, however, we want to identify data drift. We have to, well, I mean, you don't have the inference data set like a CSV file or something. And it's not possible that you can collect the data as, I mean, so say we get like one hit on an endpoint. It's not possible for us to just use that one data point to compute data drift. So in this case, we would need a certain size of data set till we actually can do data drift, right? So the way it works is that if the number of times the endpoint is hit, eventually once it reaches a certain size, certain window size, the data drift will be computed. And then for every other inference that comes in the way, think of it as the latest, the least recent data set, the data point will be pulled out, and you'll have some sort of a rolling window drift detection happening, where every time a new data point comes, it's compared with the reference data set. And all of this is for a visualization purpose, we use Grafana, and the metrics itself can be sent over to Prometheus, from where obviously you can see Grafana. Now I have, there's another, yeah, a Git, a Python package, which I've pushed in it's another repo, which can be used for doing a real-time drift detection. Yeah. And yeah, this is basically the Prometheus, the Grafana dashboard that we have. So this comes with Evidently, by the way. You can even customize your own dashboard for your own necessity. But yeah, basically it gives information on the number of drifted features, like how many features, the p-values of each test that you have run, amongst others. Right. Now this is probably the most important one. So, like, what do you do after data drift is actually identified? Right. Now, some cases it's quite more possible that your upstream pipelines have some issue. It can be the data drift is not happening in your side of things, but somewhere, like say something has changed in the way your raw data is being processed, right? Or you've probably pushed some new transformation logic in your pipeline, which is probably breaking it. And more often than not, it can also be a code issue. Now, if it is none of these, then it is possible that your data has drifted, right? Your features are different from what it was during training time. This can be for multiple reasons. Maybe you're just started to explore say a new region where you're getting a data from a different place, or sometimes you may even need to bring in a domain expert to like verify if this new relationship or why this relationship may have changed. Especially in cases like credit risk, it may be more relevant, right? And also if it is, once you identify your cause of your drift, you have multiple options. Two of them being, one is to retrain your model. Now by retraining, I mean like you just get a new snapshot of your data, and then you retrain your model. And if that works, then great. But if you're the only unlucky side, you may have to rebuild your model completely, especially in cases of concept drift, where your features and your relationship between your output has changed completely. You have to go back to the drawing board and try to identify all the relationships and build a new model from scratch. And sometimes, like during this process, like you still have to have a model operational. So it may be necessary that, for example, if you identify the cause of your data drift, like if it is like some new region or a new household income, something new, it may be feasible to filter that out and make that as an input to your model. So at least your other inferences are not impacted during this point of time, right? And of course, the last case, which is more than feasible is that it may be a false alert too, right? So if you set your statistical test p-values a bit too low or too high, and your thresholds are less, then it is quite possible that it is a false alert, and you don't really have to do anything about it, right? So yeah, I mean, that was it. What I will do is I will show a little example in Kubeflow pipelines on how the data drift is actually being detected, and then I'll proceed to show an example about the fast API. But before I do that, just want to know if anyone has any questions.
So Stephen has a question. He's joined us online.
Yeah.
So his first question was, how do you determine the window size for the online drift detection?
Yeah, that's a great question. So the window size is really up to the problem I think you're trying to solve. I don't think so. We currently set it as so there are statistical tests which require the minimum criteria to be met, right? Like I think for Z-score it is 30 samples, but it can be something which you're more comfortable with. I would say that I think larger data sets may be a bit more resilient to minor changes. But yeah, again, it depends on the statistical test and the problem that you're trying to actually solve.
So there's a follow-up. So where is the data stored to build up the window size volume of data to run the drift detection algorithm?
Yes, so data is actually stored as, let me show a fast API example actually. Let me make it a bit simple. I currently store the data. You can see the screen. I just have to. Okay. Yeah, so the data set is actually, so this is a fast API example. Now, fast API has a on event called startup, right, where you initialize this service for real-time drift detection. And I provide a config file just pointing where the reference data set is. So every time, say this is your API endpoint called API v1 predict, it gets hit. It has something known as background tasks in fast API where these tasks are run in the background, and I provide the service and the features. The data is actually stored in the backend of the app as a pandas data frame itself. So every time, basically, I just do a pd dot like just input append to each row of the data frame, and when I get the other one, I just remove the most oldest data frame the row that I have. Yeah. Yes. Yes. Oh, no. So, okay. Oh, yeah. I'm sorry. Oh, yeah. So the question is, so we used Feast as a feature store. And does Feast work? Do we integrate Feast directly with Evidently? Or, yeah, that's basically the question, right? And Feast is a feature store. Now, if you have to see the whole pipeline, like say, for example, an inference pipeline, and all these components are, by the way, connected via Kubeflow pipelines itself. So Feast would be somewhere on probably one of the first components that you'll have, where you will be retrieving your features, and you'll have your the real world data set, you can say, right? And that data set is then passed on to probably data transformation, and then you'll finally have the data drift component after that. So Kubeflow pipelines basically connects all of them together. But yeah, Feast is doing the one thing that is being a feature store and helping us retrieve the features in real time. Yes. Oh, by our infrastructure, I mean our services. Like if I have a fast API service, so what we have done here is this is actually a Python package, right? And all our APIs are actually fast API based. Basically, they just have to import the fast API, the package that we have built, which is on Evidently, and that will do the real-time drift. When I say like it works well, it just means that we can easily use it for our purposes, maybe Kubeflow pipelines or our API-based models. I'm sorry, I can't really hear you. So, no, it cannot. So as of now, Evidently is only for tabular data. Okay, I'm sorry. Keep forgetting. Yeah. So the question was that did Evidently support image data? And as of now, it does not. It supports only tabular data. But there are other tools which do for image. We have not investigated yet because I don't think we have a valid use case here yet for an image drift detection. But I mean, there is the OCR, but yeah. So for that, but I did look at other tools. There is a tool called Ylogs, if you're interested. It claims to be for image data drift detection too, but I have not tried it myself. So yes. By GCP, I mean you something related to Vertex. So yes. Okay. Okay. Yeah. So the question was that why don't we use any GCP provided services instead of relying on instead of relying on Evidently. So we actually do not use GCP cloud services. We use GKE. We use the Google Kubernetes engine, and Kubeflow runs on top of it. Now, Google's own AI solution is the Vertex AI, which is a bit expensive. And I think the idea for us is like we should use as much as open source as possible. And if it doesn't work for us, then probably look at other alternatives. For example, I think in that case, Vertex AI AutoML works out quite well. And I think we use that one. But apart from that, everything else is mainly on Kubeflow as such. Yes, by feature drift, I mean data drift. I mean, okay, so the question is the difference again between feature drift and data drift and concept drift. So if you look at Evidently, like in Evidently's case I'm mentioning, there is a dashboard for data drift, and then there is target drift, what they call as, for us, whatever I'm calling as concept drift. Yeah, so there are two different things, but it's very easy to actually also switch to target drift also using Evidently. But we haven't had at least we haven't had a use case where we have to investigate that yet. So, every use case for let's say if I see what is I haven't mainly worked on any NLP-based data drift solution, but I would think that, I mean, it's something that I need to look at. Yeah, I'm not aware of if it can be used for this. Yeah, it basically works. Like you provide two pandas data frames, it works fine with it. And yeah. Yeah, so it goes to Prometheus. Okay, so the question is, how does it I think the flow to Grafana, right? How does the metrics actually flow to Grafana, right? So we are using a fast API based service, right? And also our metric system is actually Prometheus, right? So all the metrics go to Prometheus, and Prometheus you have to define a scrape config to scrape the metrics from, and Grafana basically just visualizes that, right? So I think ours is like a 10-second scrape config or something. Every 10 seconds, it hits the metrics endpoint, retrieves the metrics, and then it's presented on the Grafana. It is, I mean, it is not time critical for us to get it like instant, but yeah, it's good that we have it like as quickly as we possibly can. Yeah. Yeah. Yes. Yeah. So the question is how configurable is evidently from statistical point of view. It is quite configurable. You can set your p-values, you can set your thresholds, your distance based. You can even customize your own dashboard if you want to, up to a certain extent, of course. And you can even write your own custom statistical test. Basically, you just have to implement their interface and make sure they're returning what they're supposed to return, and it should work fine. I'm sorry, I can't hear. How does evidently scale with more than one model? Okay, that's okay. They're asking how well does evidently scale when we have multiple models. So evidently it's nothing but a Python package, right? Like it just runs instead of you going and setting up your own statistical test, it just provides you some off-the-shelf tests which you can use. And honestly, that's all it does. It just runs the statistical tests and then it wraps it around a beautiful dashboard, and then it just publishes it somewhere, right? Now, for each of our batch pipelines or online, they just have their own evidently setup. Like I say, Pippin it's nothing but like a requirement.txt. You just put it there and then use the evidently APIs to basically just run the tests. Yeah. Per model per pipeline run. So I think, yeah, actually, but one more thing that I do want to mention, like some of the drawbacks of evidently. Like we have had issues when dealing with too many features. It's not that fast, and also the dashboards that are generated are quite large. And by large, I mean large in size itself. And that, like, I know that for larger data sets, it's possible to even reach up to like 200 to 300 MB HTML file, right? And it's because the HTML file itself has a lot of widgets, and it has. I think it even they push the whole data set along with the UI itself. Which I think, from what was mentioned, they will be working on it and making them a bit more light. Yeah. Yeah. So when I think, let me just show you a Kubeflow pipeline run, which may make it a bit simpler. Let me just. Mhm. Can everyone see this? Okay, can see. So this is a pipeline which I recently uploaded. It does drift detection. If I create a run out of this, yeah. So if you see, I've stored two data sets in GCS. One is the reference, and another is the inference. Inference meaning the real world data set. And I basically I can start it. Oh, sorry. Oh, experiment. I mean, till the pipeline takes some time to run. I can show the older one. Yeah. So basically, when it finishes running, you get this visualization, right? So you can imagine that we have inference runs on a daily basis, and this would actually be the output on a day-to-day basis whenever it runs in batch mode. Right? You have, I mean, this is the test data set. but you get like this dashboard where you can explore, like this, the green is your whatever your training data was, and the red points are where your current data currently lies, right? And we run it daily for the batch pipelines, and it's quite simple to like bring say Prometheus push gateway or something to send alert for pipeline based, and once if it's alerted, we can just take some action on it. Yeah, I mean that's what the Kubeflow pipeline based. And if we look at the API based, let me just start my app again. Okay. All right. So I have set up a very not a ML task. It's just a very simple API for demonstration. We are getting some data set like person, job title, industry, occupation, age. Yeah, I mean optional. And I've just copied some dummy reference data here, right? Which does the same. So let this be the training data set, whatever. And after this, yeah, once the features come in to the API, we basically run the drift detection when we have a 30 rows of data. Now this is controlled by using this config file here. So this config file is a YAML which you just need to provide what are your categorical features, what are your numerical features, the data format, and where is the reference data path lie. And this is the window size I was talking about, right? So what's your window size before you start detecting drift, right? Now, if I use Postman to trigger some requests and think I have to trigger 30 requests, I just click on this 30 times. Should have had it on before. It's fine. Hoping this should be. Okay, let's just see the logs, hopefully. Has it? It has. So there is some log here that it has done some high-square test. And if I go to my Grafana dashboard, okay. I don't. Right. I go to my Evidently dashboard and it's last. Right. So you get these visualizations basically telling the number of drifted features, the total number of features that you have, the p-value of your tests, right, against every feature. And the metrics themselves are like every other Prometheus service is available at you can just get these metrics here. I mean, we have used a normal fast API-based metrics exporter. So you will see from. Oh wait, I'm sorry. This is not. I was for KTP OCR. How's this running? It's weird. Yeah, I mean, the metrics are available at that endpoint. I think another KTP OCR is running in the background. Okay. But yeah, that's about it. Yes. So Prometheus is a metric scraper, right? And okay. So the question is how the metrics are being scraped. Yeah. From my local, I have started a Prometheus and Grafana Docker containers, right? And I have so in Prometheus to configure an endpoint where you have to scrape metrics from. You have to define what's that called, a scrape job or something, and you have to modify your Prometheus.yaml, and I pointed it to this endpoint of this service, right? And that's how the metrics are getting scraped. So the endpoint writes, yes. No. So yeah, there's another part of the code for the metrics point. Now I'm using a exporter called a Starlet exporter, right? It is just a Prometheus middleware, and you set it up by just telling like your app name, your metrics prefix name, and I'm giving it a / metrics endpoint, and like, basically just putting this here, and it takes care of the rest. The exporter itself does things like response time, the most of the basic ones, and on top of it, we can define custom metrics. And the custom metrics definition is happening right here. Basically, all my metrics are being search for it. Yeah, so my metric names have been divided. So metric name and metric key, things like that. I'm making it available at that endpoint. I mean, this package can be reused, but yeah, you guys, I mean, if anyone's interested, they probably have to modify a few things on things like how test is chosen, and if you want to put any p-value checks in place. Any other questions? Yes. How frequently are you yeah, so the question was that is this being used as of now, or is it just in development progress, right? It is, so we have it already in production. We have the data drift dashboards, and we have both on batch as well as API. I think what we have to work on is still like the actions that have to be taken after drift is detected, right? So now we are still, I think once the data scientists see it, we'll probably proceed to like drill down, do their own analysis on why drift has occurred. But yeah, I think there is no automated course of action that one will take once drift is detected. It's just like a tool right now, and the data scientist then takes a decision if what action can be taken once they've seen it. Yeah, but going ahead in the future, if it would be nice if we could somehow automate at least some part of the actions that have to be taken once drift is detected. How frequently are you? So for the, I mean, we have not set it up yet, but right now, like I said, it's only visualizations. But the first thing that we plan to do is set up some sort of alerting. Like Prometheus has metrics as well as alerting, right? And we plan to set up some alerting based on these metrics to ensure that if things get really bad, then we should definitely, someone should step in. But yeah, right now, I think we do keep a track of it on like probably a weekly basis, you might say, and see if things are gone wrong. Yeah. Label drift. Yeah. Yes. No, there are plans to investigate further into this. Yeah, like I said, getting ground truth for some cases it's a bit more difficult. I mean, you get to know it very late, but yeah, we are working on ensuring that we can get those two in the near future. See, I mean, okay, in case of say like AML, I would say that there will be investigators. So the way it happens right now is obviously for all of these fraud and AML cases or whatever, there will be a rule-based engine on top of it, like which first classifies like some cases as maybe AML, maybe or fraud or something like that. And once those cases have been identified, they are then reviewed by investigators to see how exactly is it actually or not. And once the investigation is complete, that time you get like it is a case or if it's not a case. Right now, we can always use that data. Of course, there'll be a big lag for it by the time it comes, but I believe that data can be used to say run a separate pipeline, which will probably run whenever the data is available and to identify things like what you just said, model drift and label drift and things like that.
And the fraud detection or actual fraud, we haven't very
Yes.
I think
Oh, okay. That question I'm honestly not sure. So fraud detection, I know it is more difficult than to identify, but yeah, are you asking? Are we trying to balance like? Oh, anyone has worked on fraud here? Data scientist? No. Yeah, but I would assume that there will be. It is a rare event, so modeling for that. Yeah, I'm pretty sure there will be some different technique because we are on ML ops team, so can't tell much on that. Limitations. That's a good question. So the question was that what's the largest data set we have thrown at evidently? I think it has not been in GBs. It has been in the high MBs at max. And the main reason for that is that it's at least if we are planning to serve dashboards, right? It is not something that's going to load in time. Like they will always hit so many timeouts before we can even. But if you are just running it on your local and you just want to like have a static HTML just to see your local, yeah, basically that will work fine. And even if you don't want a dashboard, in that case, it will still give you something known as a JSON profile, which you can, which it has its own API tools which you can parse it with, and you can get the information which you may need. Not like the visualizations as such, but things like the p-values of the test it has run, and how many features have drifted, and things like that. But yeah, definitely not in GBs. It's probably been like I think 400 MB max or something like that. Not even more than that. What is the? Okay, okay. So the question is like, what's the point between using evidently versus any of their own tests which they can run in the background? I mean, it's more about ease of use here, right? Like evidently does package everything, and when it does, it's more easily reproducible for across multiple pipelines. It's basically down to ease of use. I think no one is being stopped from running their own statistical tests. If you want to do it, do it. But yeah, this is just mainly for our ease of use. That's all. How else does evidently help us just apart from being ease of use? I mean, it kind of standardizes our whole drift based detection, right? I mean, I can imagine multiple people writing their own data drift scripts, and if being from MLOps side, it's going to be it's going to be quite a pain for us when they are just doing their own. Everyone's doing their own things. So it's more helpful for us that even if you are so everyone's on the same common platform, and even if you do want to write a common test, then evidently does provide an interface for you to do it. And it will be something that we can easily manage on our sides. So that's one more thing. Oh yeah. So like I mentioned earlier, there is Y logs. There is another tool called Boxkite. Yeah, there are a lot of data drift tools out there. It evidently is just one of them. But yeah, I mean, of the thing, couple of things that we did see evidently did pop out, and it was like good enough for our use case. And yeah, that's why we chose it.
Yeah, most GitHub stuff.
Yeah, that's how we choose stuff. Yes, it's GitHub stars. Okay, yeah. Thank you guys all for joining us today. Yeah, and hopefully, please submit your papers of your own, and we are going to planning to do this monthly. So it'll be great to have some of you guys who are online to, or even offline, to come over here and present. Yeah, thank you. Meetup now. I'm still presenting.